Okay, this is the SIG Automation meeting for August 24th, 2022. The agenda is presented. We're now on the screen. Before we jump to Tao, I guess the administrative things is the nominations for the vice chair has actually ended yesterday. So we have 2 self-nominees. So I believe next week TSC is going to go for it, and then we'll know between Cal and Wim who's going to be our vice chair. And for today, it's basically only have one agenda items. Tao is going to present the bifurcated orchestration for CNFs. So without further ado, go ahead and present.
Thank you.
Get out of the way.
Share. I can share a tab. I'll be interested. Okay. Share this window. Sorry, every video thing has its own style. So here we go. Did that work?
It is going. Yep.
Okay, good. So yeah, it's the only thing on the agenda, but I intend this to be a discussion as well. But at the same time, I want to make sure that I do finish the entire argument. So feel free to interrupt me, but please use your judgment, whether it can wait until the end or it's worth stopping me where I am and asking a question or making a comment. Happy for both. My goal today is to move us forward constructively. I try to present something as straightforward as possible. And a lot of my thinking and some of our thinking in Red Hat in terms of how do we solve this problem of delivering network functions on Kubernetes. It's mostly an analysis, but I also come to a conclusion at the end. You might disagree with the conclusion or have issues with it. You might also disagree with the analysis. We'll see. But I think it's pretty straightforward, and it might even be obvious for many of you. But sometimes you just need to say what's obvious to make sure that we're all on the same page. So here's the starting point. CNFs assume strong vertical integration. We're not the only industry that does this, but I can say it's characteristic of many CNFs. I call this structure a tower. You can think of it as a stack, but I think the word stack usually refers to something in the platform that we build on top of. In the case of a CNF, the whole thing is a stack from end to end, from bottom to top. So I call it a tower. Components there, I'm giving them a very general sketch here, things from the motherboard, CPU, RAM, GPU, network interface cards, the operating system, the container runtime that runs on top of the operating system that actually runs the containers for us. And this, usually it's CRYO, it could be the Docker runtime. Then we have the orchestrator, right, which is Kubernetes itself. And finally, on top of the orchestrator, right, if all the bottom is the stack, the top part is the actual workload. That is the actual CNF. But for the CNF to function, it could rely on parts of all of this and changes to all of this, right? All the way to BIOS changes in the motherboard. And this is a challenge. This is definitely a challenge, because if we deploy network functions only in terms of the Kubernetes workloads themselves, we have the problem of how do we get to access the rest of the stack. And we've seen many workarounds and many solutions. One of them can be to use privileged containers on the different hosts to make changes to that host. Sometimes that can work, but obviously a big security problem, organizational architectural problem, right? The workload is changing its own cluster where the cluster should be provided for it rather than something that it should change. And sometimes those changes are impossible. For example, Red Hat uses mostly CoreOS as the operating system for Kubernetes, and CoreOS is specifically locked down. and designed to run containers. So it's not supposed to be easy to change or things like that. You can't just install a package in CoreOS, not easily at least. So yeah, this next slide, I just want to remind us that the first slide is a simplification. We're thinking about clusters, so, and sometimes even multi-cluster workloads. So just keep in the back of your mind that every node duplicates this whole thing, right? So if all the nodes are identical, that looks like it might make things easier, but not necessarily, right? Because if we have multiple network functions running on a simple cluster, they might have affinity and requirements that would not conflict with each other, but would need to be coordinated. For example, SRIOV, you have a limited number of lanes you can use. So you might have to share, you might have to distribute network functions over several nodes if they don't have enough resources on one node. Same goes for NUMA pages, etc. So here I want to deep dive a little bit into, well, who manages what, right? What are, if we think that our workloads are defined as Kubernetes resources and they could use custom resources too, right, that are extended with operators, that's kind of the simple part here. I call it workload management. I am mentioning here in parentheses that it's not that simple, right? There are aspects of Kubernetes resources that might require administrative privileges, right? If part of what the network function needs is, say, to create a namespace, create a service account, create a custom resource definition, those would need privileges, right? So within the workload, there are some divisions we'll get to a little bit later. There's much more going on in the rest of the system here, right? The operating system has some responsibilities in terms of the hardware, right? But so do aspects of the motherboard, right? Sometimes the BIOS needs to be configured to enable or disable or configure very specific features, right? And I mentioned here with operating systems too, that that's also where some aspects of Kubernetes come in, right? If we have CNI or CSI plugins, specific ones that are needed for a network function, well, they might have to have some operating system level installation and configuration, right? So it's not purely just the container runtime. On the side here, on the left side, and I'm putting it on the left on purpose, we'll see later why, I'm putting this box that I'm calling a manager, and we're going to deep dive into it a bit. But I wanted to show that the manager is in charge, responsible for all this stuff on the left. The stuff on the left is oftentimes called installation, right? Installing the cluster and setting it up. So the manager would be in charge of, for every node in the cluster, if it needs to configure the BIOS, it will install the operating system with the drivers, the CNI and CSI plugins, hopefully. It would install Cryo and configure it and install all the Kubernetes services that are necessary for that distribution. So the manager seems to have a lot more responsibilities than what Kubernetes does, but I would say it's not so much more responsibilities, it's just more diverse responsibilities, because each of these things are very different kinds of tasks. Whereas in the Kubernetes world, on purpose, we've created a declarative environment that is always follows the same paradigm, right? So we see kind of a complicated stretch of lines here. And I just want to make sure that we understand how all of this works together. So this is just a sketch of how all these lines connect usually, right? When we need to orchestrate a CNF. So it starts with the manager having to select a node within the cluster that meets the hardware requirements. Or if it doesn't meet them exactly, it could be configured to meet those requirements, right? Sometimes it looks like the node is okay, but until you actually, say, speak to the BIOS and check something out, you find out that actually it's not okay. So the manager needs to do some work to discover and detect the nodes and their capabilities. If everything is okay, there might still be some policies involved regarding what we want the network function to run on rather than what it can run on. So we might have some preferences for some nodes versus others. And of course, it could be multi-tenant issues too. If we know that this node, this network function will be running in tandem with other network functions, well, maybe that's allowed, maybe that's not allowed. So that could sometimes be an issue. Once the node is selected, the manager reconciles the node, right? I'm using a declarative language here, right? Because we're all thinking declaratively. So on day one, that means installing and configuring that node. On day two, it means reinstalling, possibly reinstalling, but definitely reconfiguring that node. We always want to avoid reinstallation of the whole node if we can, but sometimes there's no choice. And the scope here is very broad, right? What happens when the node is installed is everything, right? Configuring the BIOS, installing the operating system, Kubernetes, the drivers, the plugins. And I'm also mentioning here operator CRDs. Well, it might, if this is a question of whether we treat certain CRDs as part of the platform or part of the workload. It's something I've gone into in another document I've shared with you. I won't delve into it too much. If you don't like having operator CRDs here and part of what the manager does, you can throw it into step 3 if you prefer, which is actually orchestrating the workloads. And that's straightforward Kubernetes at this point, at step 3, which is day 1 and day 2 as well. I'm mentioning here that it doesn't have to be completely independent. The manager can install certain policies, Kubernetes policies on that node, and those policies could be used by the network function to orchestrate itself. Okay, so here's the kind of interesting intervention. I mentioned in our meeting, I think on Monday, that in the architecture SIG meeting, that I think one of the most interesting aspects of Nephio is our basic assumption that the manager, right, this box here to the left, is itself a Kubernetes cluster. That's not at all obvious, but it's very powerful and very important. And I'm happy to have all of us aligned there. Well, why? Why would it be a Kubernetes cluster? Well, the manager does a whole bunch of things, right? It configures BIOSes, installs Kubernetes, configures the nodes. All of these could be done by certain services, certain applications. It makes a lot of sense to run those and install them themselves using Kubernetes. Once we do that, we're still in the Kubernetes paradigm, right, of a declarative environment, and we can use the extensibility in Kubernetes to extend our manager, right? The manager itself becomes something, a domain, which we can interact with and intervene into using the usual Kubernetes paradigm. However, I'm emphasizing here that while that is true, remember that the management cluster is a different universe of resources than the workload cluster. In the workload cluster, we deal with Kubernetes stuff that we're used to working with, pods, services, and maybe our custom resources, right? In the management cluster, we're not running our workloads there, right? We're running stuff that is supposed to manage the workloads. So we're going to deal with maybe our distributions installer, right? We talked about the cluster API. Maybe the cluster API will be called then. Maybe that's where we're also managing SDN for our entire cluster or multi-cluster environment, right? So the kind of resources we're dealing in the management cluster are different than the kind of resources we usually work with in Kubernetes. But the paradigm itself is the same. So here, going back to that earlier slide, here are the two classes, I call them, of clusters, right? In yellow, I'm putting the management cluster in the management domain. In cyan, I'm putting the workload domain, the usual domain. So you can see the workload domain really is just one line here. As I said, it doesn't mean it's fewer responsibilities. It just means they're less diverse. The yellow lines are a lot. There are a lot of different things that the management cluster deals with, right? From installing the whole clusters themselves and setting them up with all their networking and all that involves, the operating systems, configuring drivers, etc., and even BIOS, right? So the yellow lines here flow. There are many of it that belong to the management cluster. Now, if I was good at presentations, I would be able, I wanted to show an animation. So imagine this tower, right? The CNF tower here in the middle that I'm pushing it over like a Jenga game maybe, and toppling it. And then all the pieces here are going to be jumbled on the table. So I toppled the tower. And then I take all those pieces, and now I'm saying, okay, I have these puzzle pieces, which are basically all the requirements of the network function. And now I'm trying to organize it into left path versus right path. What belongs in the management cluster? That is, what has to run there to take care of that responsibility, that requirement, and what would be in the workload cluster. So on the one hand, it's very easy. You say, well, all the workload cluster stuff is just the workloads itself, right? The pods, services, etc., and everything else in terms of hardware and operating system will be in the management cluster, right? Host requirements. So if it's BIOS, if I need BIOS, if I need NUMA nodes, if I need a certain kind of CNI plugin for Multis, if I need certain drivers that I'm expecting to be running already on that node, if I need access to the GPU, if I need SRIOV configuration, if I need a real-time kernel, right, which some network functions require, well, all those requirements, if I'm listing them, should be under the responsibility of the management cluster, which I'm here calling the left path. In the middle, I'm showing that there are a bunch of things that, as I said, could go into either cluster, and it's more of a matter for us to decide where we want the responsibility to lie. I'm going to get into this a little bit more and kind of suggest maybe where is a good place to put the line. But right, all these things have to do with administrative privileges in Kubernetes, right? So, you know, if the workload requires these things, and usually they do, the question is, should the management cluster take care of them, or should it be something in the workload cluster that could do that, possibly an operator with certain privileges, RBAC privileges in the cluster? It can go either way, right? And where to draw the line really depends of, do we want to give the orchestration users admin privileges? That is, whatever installs the network function on the workload, do we want to give it admin privileges? We might want to, and we might not, right? And that depends on where we want the responsibilities to lie. So we can control if we want more stuff on the left path or more stuff on the right path. There's a certain simplicity to move things to the right path, because we can say, well, that's kind of the way Kubernetes always works, right? If we ignore all the stuff on the left, the telco requirements, then how do other industries use Kubernetes, right? They just talk directly to the cluster. They don't even think of a manager or a management cluster running somewhere. You just deal with workloads 100%. But since in our world, we have this idea of a management cluster because we need to deal with all this stuff, we have a certain advantage where we can say, well, we do have two paths here, and we can be more deliberate about it. We can say, well, maybe it's a good idea to manage all this stuff on the left path. So I'm just putting this out there as a decision that we can make. And I think there are pros and cons to each. What I do want to emphasize here is please don't make the wrong assumption here that I've seen some narratives, people tell the story, this orchestration workflow story, where it's, well, the management cluster is day one. The management cluster installs the workload cluster for us. And when it's done, you know, it hands it off to normal world, right? The normal world of Kubernetes, where day one and day two stuff happens in the cluster is done. This assumes, right? I say immediately that we cannot make that assumption here. This is not a good idea to make this assumption, because these things on the left, you might think of them as static requirements that never change, but in fact, they are dynamic. Day two changes to network functions can involve scaling up. Scaling up might mean, oh, we need more SRIOV lanes, right? Maybe we want to ask for bigger NUMA pages, right? There are changes to day two that could absolutely involve changes to these requirements. And that means that they need to be reconciled, reconfigured, etc., right? As I said in this slide here too, it was here, right? We think about reinstallation and reconfiguration. Now, obviously, we don't want to do a complete reinstallation of a certain node. or definitely not a whole cluster, right? We might want to reconfigure a new node. It could be something simple, right? Changing something in the BIOS and just rebooting the node. So in terms of making this effective, sure, we want to make this as efficient as possible and as fast as possible, but it doesn't mean that this is outside our scope. Day 1 and day 2 changes happen on both clusters. And that's in line with declarative thinking and intent-driven automation, right? That we're continuously reconciling our intent with reality. So that's what I want to make sure, that we don't have that narrative in our mind that the management cluster is day 1, and then it hands it off. Both of those clusters are continuing to do work. Maybe one more than other, but they're still both important. And we're getting close to the end here, and we can discuss. But I wanted to talk briefly about moving towards a conclusion here in terms of, well, okay, there are different options here. We have this left path that I'm calling, working with the management cluster versus the right path. I said there are pros and cons about moving responsibilities between the two, but there's another strategy that you need to decide in terms of your orchestrator, your OSS system behind the scenes, whatever it is that is talking to this and actually deploying network services by decomposing them into network functions, etc. Should it be talking to both classes of clusters, or should it only be talking to management clusters? Now, again, this is not the kind of decision that you have to get into the usual Kubernetes world, right? In the usual Kubernetes world, you think about the manager as just being, well, it manages. I'm talking to it. Maybe there's some sort of RESTful API call or a fake RESTful API call. Install this cluster for me, do something else. But remember, we're assuming that our manager is also a cluster that we can interact with and install things into and extend with custom resources, etc. So we have the options here to either do what I call bifurcated access. And I hope you understand that, the title of this presentation, bifurcation, I'm using that as a metaphor here to kind of steer us to thinking of, there's a one eye on the left path, which is the management cluster. Another eye is on our workload clusters, right? And we're constantly looking at both paths. So one way we can access this is really doing both, right? Bifurcated access, I'm calling it, where our orchestration client will talk both to the management cluster and to the workload clusters. So it would talk to the management cluster when it needs to deal with all these things on the left, right? So if it needs to request a real-time kernel for this network function, then maybe there'll be a custom resource within the management cluster where it defines the real-time kernel that it needs, something like that. That would be a Nephio operator, right? So there might be a Nephio operator running here in the management cluster that picks up on that for us. But then we say, well, we don't want the management cluster to do any more than that. We only wanted to handle those things that we could not handle in the workload clusters. So now for all the regular workload cluster, all the regular Kubernetes stuff, we'll just pick the right path. That means the client needs access to everything, right? The client here needs access to all the management clusters. It needs users there. And of course, it needs a way to access all the workload clusters. This is usually not hard because we assume that our OSS or higher level orchestration system has an inventory management. So we can get credentials and users to access all the workload clusters, right? And we are assuming that the management cluster will update that so we know what our workload clusters are after they're being installed, right? So this is not an impossible strategy. It does move a lot of the responsibility on the client here to decide what goes where and how to decompose requirements for network functions into these two domains. Another approach we can take is it's simpler in a way, right? We say, well, because the management cluster manages, right, the workload clusters by definition, it knows about them, it already has access to them and everything. Why not let it handle everything? I call this the delegated strategy. And here we have the client only needs to talk to the management clusters, right? It still has an inventory of workload clusters and it knows their IDs, knows where they are, it knows where the network functions need to go, but it doesn't access them directly. It rather it asks the management cluster to get delegated to them, right? So I don't know, if you think, for example, that you have a Helm chart for a network function, which I do not recommend, but let's say that's where you are, you can send that Helm chart to the management cluster and ask for something there, probably an operator, to install that on the many workload clusters that it has, right? So this is left path only, right? And if you think of these two strategies, I mentioned this a bit, but the bifurcated access strategies, as I said, you do need access to all the clusters, right? All the workload clusters, as well as the management cluster, which I think this is what we already have set up, right? Yeah, another aspect here is that could be important. Remember, in all this orchestration stuff, this declarative environment, the Kubernetes stuff is usually very fast, right? We assume very ephemeral. These are basic assumptions in Kubernetes that pods are ephemeral, right? They can be destroyed very quickly and recreated very quickly. If you don't follow those assumptions, you're going to have a bad time, as we know. But the idea is that a lot of your resources are fleeting, lightweight, as many as you can make are stateless, and they come and go. Right? And you have sometimes an eventual consistency where you don't even know that some pods have been destroyed or services have been destroyed, but you make sure that higher level operators will recreate them if they need to. Many things are throwaway, except that when we deal with the management domain, things are not throwaway. A cluster as a resource is not something that you just create easily. It can take a very long time to install a cluster, right? Or reconfigure a node, or even just to reboot a machine. So we're dealing with a domain that is less ephemeral than the usual domain of Kubernetes resources. This means that if you have a regular declarative Kubernetes client, you can have a weird situation where you create a custom resource and maybe you're waiting for the resource to be created, for the status to be updated. It can take 45 minutes, right? So if your orchestration client is not used to working in this kind of extremely asynchronic environment, you have a challenge here when dealing these two domains. They're both declarative, but they both have some different assumptions over the life cycle of those resources. And then again, you have the responsibility here to sort your requirements between the left and right paths. So you have to decompose a network function, right? If the network function is packaged with all its requirements and it's just listing requirement after requirement, I need this BIOS configuration, I need this number of SRIOV NICs, I need these NEMA nodes, and I need this pod, and I need this SDN connection and these networks, etc. It will have to sort what needs to go into the management cluster and what needs to go into the workload cluster. The delegated access model, right, this one here on the right, which I only go through the management cluster, is, I think, simpler in a way, right? Because we only have to deal with one, we only have to talk to one cluster, right, the manager, and we expect it to do all the sorting and the delegation and do the right thing. So this is simpler, right? We have only one point that we need to access. But if you put more eggs in that basket, it means that management cluster becomes even more important, right? It cannot fail, right? If you have this idea that in day one it installs and then on day two you take over with a workload cluster, well, if that's your narrative, if the management cluster fails, no big deal, right? It did its job, it's done. It installed your cluster, it can go away. But here we're really thinking that we need that management cluster always up because it's doing reconciliation as part of our process, right? So it becomes more important. Yeah, and I do mention that there's, another advantage here is scalability, right? Because if we only talk to the management cluster, the scalability problem moves to that domain. And this becomes interesting if you think about multi-cluster workloads as well, right? Because if you have multi-cluster workloads, again, the management cluster can do that kind of decomposition and know what goes where, and maybe deal with also the connectivity between the clusters if it needs to do that. It has that view, right? Whereas you as a client might not have that view. And I'm almost done here. Here I want to get into what the implications of all this analysis is. Assuming you've gone on this journey with me from the beginning to the end, you kind of understand the challenge here that we have strongly vertically integrated workloads that require separation, maybe into left and right paths, because some responsibilities would be on the management cluster, some responsibilities would be in the workload cluster, and you kind of see that we need to think about this left path versus right path. We have different strategies we can do. What does that mean for us in Nephio? So here's the big deal. If you want an operator, if you want to package your network function with an operator that should manage that operator for you, right? We said before that's not necessarily a great idea to put everything in one operator. So it might be a constellation of operators, right? Some of which might be Nephio operators. But let's ignore the internal composition. We have at the top an operator that manages the entire network function. Where should it live? If you're thinking of only one, if you had multiple operators, and you can say, well, some of them can run on the workload and some can run on the management. But if you only wanted one, really your only choice is the second strategy, the delegated access. If you could only have one operator for your network function, it should run in the management cluster. That's what I'm saying is the big deal here in my conclusion, because this is so not obvious. Right? I think if you've been working with network functions and packaging them with operators and experimenting with this, you've probably thought about, the usual thing. They're running in the workload cluster. That's where they do things. But you've probably also hit all these roadblocks where you have to do things in the hardware. You have to do things on the host. And you can't do them there because either you need privileged containers, which introduces so many problems. But sometimes even with privileged containers, you have the chicken and egg problem where the cluster has already been installed, but you need to go back to the actual installation of the cluster. So what Nephio does for us here is, with the assumption that the manager is itself a cluster, we suddenly have the opportunity to run our operator there. And from there, it has access to the complete life cycle. It could affect the installation of the cluster itself. And then it could also, do the delegation of the workload after it's done. So we could have one operator doing everything for us, but if we want it to do everything, that it has to be in the management cluster. That's my big conclusion that surprised me a bit when I got to it, because it was not obvious to me at all. But some aspects of it, if it's running there, it will be interacting with the management cluster's resources. So all those things like BIOS configurations, GPU configurations, real-time kernel configurations, etc., and the installation of the cluster itself. But it could also interact with the workload clusters as usual. It would do that just by being a regular Kubernetes client, API client to the workload clusters. So it's not like we can't do workload stuff in the management cluster, but we're doing it just like any client does, because we're running from outside the cluster. And to be honest, it's not so different, right? If you've ever worked at the API level developing for Kubernetes, you know that even if you're running inside the cluster, you're using a client API. It's configured automatically for you if you're running inside the pod, but if you're running from outside the cluster, you just need to give the credentials and the access. But the API itself is the same. You're always talking to the Kubernetes API service, whether you're from inside or from outside the cluster. So really the change here is not very big. It's more about getting those access credentials. But again, the management cluster already has those access credentials because it created those clusters in the first place. Also mentioned here in parentheses an important aspect, and now I'm reaching the last slide, I promise, that it doesn't have to be one operator, right? We could say that as soon as the network function gets installed, we're also going to install an operator there at the workload cluster that will handle things at the workload cluster. So doing the local work, right? If we don't want everything to go through remote access, right? And this is really the final slide, and this is kind of a proposal how to build an operator for a CNF. Actually, bifurcate it. Make one part of it run in the management cluster. And that's the only thing that the user has to care about when installing. They install, as I said, that's the big deal here in red, that we install our operator here. But then after we install it here, it will install a workload operator in each cluster. to handle the other things, and they can work together, right? This can update custom resources for it to do its work. So we don't have to have a lot of chatter going on all the time here. So we could really minimize that chatter and make sure that work is done locally, which is always the best. Rule of thumb, your code should be as close to your data as you can make it. So if we can get most of the code here, you know, the management operator part might just be a kind of seeding of those workload operators. And of course, talking to the other resources here in the management cluster to configure what we need. And that's it. I'm done. This is my final conclusion. Is everybody still alive? Awake? I would be happy to hear comments, questions, any kind of feedback.
I have.
Yeah, we are alive and awake, Charles.
Good. Hi, Ben. I see your hand is up. Go ahead.
Yeah, go ahead.
It's me, Win, or okay.
Good. Yeah.
Sorry. Yeah. So thanks for the presentation, Tal. So that's I think a good overview of, or at least some thoughts on the thing, right? A number of questions. So on the last thing, when you said a network function can run on the management cluster, do you assume that the network function, so a single entity, can span beyond a single, let's say, let's call it workload cluster for the time being. So let's say SMF, UPF, radio. My assumption so far is that they can only run within a single cluster. Now, of course, you can have multiple instances of that.
Right. Yeah, let me clarify. I did not mean that the workload runs on the network function still runs as a workload in the cluster, but the operator, right, the managerial side, the orchestration side, I'm saying only that should be running.
Now, I think what also one of the, let's say, discussions, or let's say at least it was discussed, I think, in the summit somehow, that we kind of wanted to ensure that if something fails, that the whole thing still operates, right?
Right.
So as a result of that, my assumption is that let's say, because I think you can split the operator that you call into different layers potentially, right? Because if I take let's say, if you look at John's presentation, what he basically does, he uses the management cluster as a way to prepare everything. So it runs a lot of stuff to do a bunch of things.
Right.
And eventually the result will end up in the workload cluster, right? And that's a result of various transformations and mutations and what have you. And the result actually is then applied onto the workload cluster. And my assumption is that the operator for that network function runs in the workload cluster to ensure that you have full autonomous operation of the network function and so on and so forth. But of course, the areas, so the concerns are split into two things. So there is certain pieces that run on the management cluster, because you probably, as you said, you have what you call the management. I think, what's your exact name? I forgot. The management cluster, you call it. I look at it more. If you look to the Nephio architecture, if I was looking up the diagram, you see cloud and infrastructure resource. For me, your manager, in my view, is the operator that does all the cluster installation. And also there you can split it. So for me, there's an operator indeed runs on the management cluster, right? But it basically takes care of the infra, meaning the clusters, the SRIOVs, the NUMAs, exactly like you said. But it's an operator because you cannot run it in the workload because there is no workload yet, right? So, so I fully agree with you on that side. That that manager has to run on the management cluster, but I see it as a operator that takes care of the infra on which the workloads eventually run.
Right. I assume that within the management cluster, you have a bunch of operators running, which will be a combination of Nephio operators and vendor operators, right? Red Hat has a different set of operators and policy management. This is the differentiation we have between vendors, right? Google has its own
Correct.
own set of management challenges, right?
Yeah, correct. And then depending whether you run it on GKE, you don't even, if you run it on the public cloud, you don't even have access to certain resources. Like you basically can say, okay, I want Azure IRV, or I want this or that, but there is certain restrictions and stuff like that. So for me, the manager, I see that as an operator, takes care of the infra resources, right? And of course, you can split it into multiple pieces potentially, depending on what we want to achieve. Right?
I do want to quickly just address something you said about the issue of stability on day 2, right? That we don't want to create a dependency. Yes, this is exactly the proposal that I'm saying at the end here. I'm saying if we make the management, so we want to have the management cluster and the operators running there to have as little responsibility as possible, right? Because we don't want to make that dependent. We don't want everything to fail if the management cluster goes down. If that's a requirement for us, then we need to delegate as much work as possible to the workload once it's set up. And also, I should say, these day 2 changes to these requirements on the left are possible, but they should be rare. And in certain cases, they might be forbidden, right? You can say, well, if you want a new NUMA node, sorry, you can't because the management cluster is down. So
I 100% agree with you. And the left side, I fully agree with the three areas that you present here. But the left side should also be managed in a declarative way. Right?
Exactly.
So exactly as the middle one and the right-hand side. So we should manage the left-hand side in a declarative way. So that's why, from my assumption that I took so far, is that the infra or the infrastructure, which let's say summarize it as the cluster or the workload cluster configurations, has to be managed in a declarative way, one way or another, right?
Absolutely.
And that's
the basic assumption here. Yeah.
What the left side basically does. The third comment that I was going to make is I personally would love us to get to the point where you basically split the responsibilities in those 3 sections, right? Also, if you look to the Nephio architecture, they have exactly those 3 sections, right? If you look to the drawing of Nephio, I think I just have it here with me. So you have cloud infra, you have workload resources, and you have workload configuration, I think, which is exactly your 3 buckets. So the left, middle, and right? Now, the challenge that we have today, and I think you mentioned it in your talk, is that as Nokia, we deliver you a Helm chart, right? And it contains both the middle and the right.
Right.
And this complicates the work somehow, because as you rightfully said, now we need admin privileges and what have you, right? And I think this is one of the opportunities that we have. If we could split, if the workloads could say, I want so of course they come with CRDs most likely, right? I can say, okay, I want these infra resources, because at the end of the day, if you look, the middle column is actually the core Kubernetes elements, more or less.
Right. Kind of the admin layer or the control plane, if you want, management
kind
plane.
Of core Kubernetes, what is in the middle, right? And basically what those workloads say on the right, hey, I want these core resources from you. And of course, the CRD is maybe an odd one, but actually, if you look to CRD as a core resource, of course, you can have different types, right? But I classify the middle layer as the core Kubernetes API elements that the workloads rely upon, right? And as such, if we can decouple them, this would be ideal, because I would love to go to your delegated architecture, because that allows us to split really the responsibilities.
Right. If I translate what you said, right now, if say a vendor, let's say not Nokia, a vendor is creating a Helm chart packaging a network function, well, you probably would need 2 Helm charts, or maybe even 3.
We have to split. Yeah.
Right. Yeah. And you need to do them in order, which ruins the whole declarative approach. The declarative approach is that you don't care about workflows. You don't care about order of things. You declare all your intent.
Correct.
And life cycle is something that is hidden away as an implementation detail.
Correct.
The life cycle is binary. Either the resource is there or it's deleted. That's your life cycle as far as the user is concerned, right? Which is amazing in terms of orchestration. Right? We're shifting the buck. Of course, life cycle happens behind the scenes, but we no longer have to get involved in it. But then, if we also have these, you would have basically 3 Helm charts. You'll have 1 Helm chart going to the management cluster. Then you have to wait for that to end deployment and say, okay, the cluster is ready. Now you have to deploy all your Kubernetes admin stuff, wait for them to be done. Only after they are done, right, you can actually deploy your 3rd Helm chart. That's kind of insane. We've been doing that, but that's been insane. So I do think there's a certain advantage to just having the left path where we just deploy everything at once. We have 1 Helm chart, a whole bunch of resources, and let the management cluster figure out the life cycle of this.
It
right?
should be like that, yeah. And then you have really declarative operation, right? And that's
Right.
That's I think or would be my objective to go through such a framework.
Yeah, I'm leaning towards that too, but I just want to be aware of the pros and cons. And
Sure.
the truth sometimes might be somewhere in between. You might, if you're working with systems, because this does require a change in thinking, right? That you're working against a management cluster rather than the workload cluster, right? This is why I said it's a big deal. This really changes our whole way of thinking about deployment. So we might not want to make it a big deal. Big deals are costly. So it might be cheaper to think of some sort of combination of these 2 approaches. I don't know, right? I'm just kind of analyzing the problem here.
Oh, okay, thanks. Sorry.
Thank you so much. Thank you for your comments. I think you understood it exactly. So I'm happy. It sounds like I was able to explain things well enough, at least for you to understand. Thanks.
Paula's next.
Sure.
Go ahead, Paula.
Yes, Stephen. Thank you. Yeah, good presentation. So I think many points that I was going to bring up is kind of covered in the previous discussion. So the main point I wanted to make was, it has to be just enough in such a way that even if a management cluster going down should not affect the day-to-day workload operations, it can go down and come up. For example, management cluster should not. So I think that's the intent here as well. So that is good. The second thing I was thinking is in this in the bifurcated CNF operator approach, the client's dealing only with the management cluster. The other some of the other advantages could be use cases where a workload needs to be installed in more than 1 cluster. So
Right.
at which point of time you can express the intent, the client, and based on the candidates' workload clusters, it could be deployed in multiple workload clusters. And the other thing is, since we are specifically targeting RAN workloads, especially the DU workloads are going to be at scale. So a client dealing with each and every DU workload may be too cumbersome, even if there are a handful of CUs here.
Exactly. Yeah.
So putting that onus back into the management cluster and expressing the intent and letting it do the job would be desirable, because that will take away a lot of hand-holding from the clients, because a lot of it doesn't care. It just wants the work to be done, and management cluster can have the picture of the entire network domain, and it can orchestrate things based on.
That's exactly my thinking. So I kind of snuck it in here, but every time I put 3 lines, I'm trying to emphasize that there's a one-to-many connection, right? And I also write workload clusters rather than cluster.
Yes.
And now, this is something we talked in the Nephio Summit as well. People asked, should network services be part of the our scope? And I think most of us don't have appetite to involve network services in Nephio. That's just too much to handle. But at the back of our mind, we know that we need to, of course, allow for that decomposition and recomposition of network services. So definitely the management cluster is where this could happen, because it has a multi-cluster view, right? We're assuming that one management cluster manages many workloads clusters. And it's not in Nephio scope, but this management cluster is where we can also run a network service orchestration element, an operator, right? That could do that decomposition, that 5G decomposition into CU, DU, and it could be very sophisticated. It can have all of the ORAN configurations, for example, right? I forgot they're all numbered. And it could choose maybe the best one for this network service and make it so, right? It can choose a certain configuration of CU, DU, mid-haul, backhaul configurations, etc., and deploy a blueprint exactly for that ORAN scenario. All right, so you have amazing power, I think, as a management cluster. So that would not be in scope for Nephio, but it's something that Nephio could enable, right? If Nephio creates a very declarative way and centralized and easy to understand way of managing network functions, the network service composition and recomposition suddenly becomes a very trivial problem, because it becomes just another operator in the operator chain, right? You will have a network service decomposition operator that will generate, it will accept some sort of input of what you're trying to do in the network service, and then output a bunch of custom resources that will then be taken up by Nephio and by vendor-specific operators to deploy all those network functions in a multi-cluster way. I mean, that would be a beautiful narrative, right? Let's hope we get there.
Yeah. The advantages I could think of is obviously the closed loop automation that we could achieve. It could collect it has a view of the world, it has view of the metrics, telemetry, and it's know what's going on. It can take some decancellation actions based on what's happening in the workload clusters, move workloads, and these are some of the advanced use cases. But those are possible with this architecture.
Right. And again, I want to make maybe a little warning here. If it sounds like we're talking about centralization and moving everything into one place, well, we're only talking about declarative stuff there. The actual work, the lifecycle management, everything should always be local in the workload cluster. So these operators should usually be very lightweight things, right? They're just dealing with state, and they're just applying policies, and it's a bunch of if-else statements. They're not doing any heavy lifting of provisioning resources and things like that. Kubernetes already does that well, right? That's what we're leveraging here. So this is not centralization of work. It's more centralization of decision-making, in my view. Yeah.
Exactly, yes. Yeah, I agree with that, yeah.
Yeah.
Time check, 5 minutes left. So go to the next one. This Vaughn.
Yeah. So fortunately, you've told most of the things that I wanted to talk about. So only thing left to me to point out is that if you decided to do GitOps because you have to, because it is a company policy in your company, or it was decided for you, but whatever, you start with the assumption that you will use GitOps, then it will make most of the choices that you presented here for you. For example, you have to do this delegated left-hand side only access path, because most of all of the configuration changes in the workload clusters has to go through a central Git repo, and your GitOps tool will be running in a management cluster somewhere that will push down the configuration. And just one point, and I will let, just because we have that, this also means that all of the operators that are running in the management clusters, doing some configuration changes in the workload clusters, for example, in the configuration CRDs that are interpreted by the CNF operators that are running in the workload clusters, has to modify the Git repo in order so that the GitOps tool will be pushed down into the workload cluster. So all I'm saying that this is another option. So if you decided, or it is decided for you, that you have to do GitOps, that will limit your room for this kind of choice.
No, you're exactly right, and I'm not presenting this whole presentation as a revelation, something that I invented or Red Hat invented. I think a lot of us are already thinking like this already, and we're sometimes by necessity, right? So Red Hat, we use Argo, as you know, for our CI/CD. And we have ACM, the Advanced Cluster Manager. So we've been doing this management cluster thing for a while, and already extending it and putting things there, and already thinking about this delegated access path. And you're right, a GitOps workflow can enforce that. I don't think it has to. I think you can design some GitOps thing that, a GitOps workflow doesn't have to be in serial, right? You can be in parallel. You can have different components taking different parts of the GitOps repository and each managing their own domain or subsystem. So you could potentially have one set of controllers, operators, managers, etc., handling the right path, and other doing the left path. But that, again, that probably implies a very static decomposition, right? If we want to think of decomposition more dynamic and more involved in decision-making, then yeah, I think that kind of implies that you need this delegated access, what I'm calling, the left path only. So it's true. I didn't talk about GitOps at all here because that to me is all in the client. I tried to simplify and only talk about what we need to do on the Nephio side. But obviously, all of these have profound implications for the client, right? That's why I call it the implications. That should be the next presentation, implications.
Daniel,
Thank you.
we still have a little time for Daniel.
Yeah, just one small comment. I think the importance is really around your slide 8, to be honest, Al. It's what goes and stays in the management cluster. What, like, for example, to me, and you can declare the definitions within the management cluster, like you said, Argo and things like this, but the decision making on the implementation, the closest it is to the workload, so like separation of domains, to me is the best one. I would not have, for example, CNI plugin definitions. It can be defined in, for example, in Argo in a management cluster, but all operations needs to run local as much as possible.
Yeah. I mean, Argo is great. I love Argo. It solves a lot of problems, but it solves problems that we've created, that Kubernetes has created. This idea of the chicken and egg problem that's always there. Like in a declarative environment, you shouldn't be thinking in terms of workflows, right? You should be thinking, here are my resources, here's my intent. The platform should figure it out. But Argo is a way to implement workflows inside Kubernetes. So it's taking one paradigm and kind of shoving it into another. And I think we're all a little bit uncomfortable with that. It works, right? So you can say, okay, create the CRD, wait for the CRD to be created, and only then you can create the CR, right? Which we know is a requirement. It's built into the way Kubernetes is designed. So Kubernetes requires us to kind of do something a little bit non-declarative here, right? I've written an operator that tries to solve that in a different way too, by kind of queuing resources. But again, these are kind of band-aids rather than the right solution. The right solution, I think, is really thinking of this comprehensively. And we're not just thinking about CRD and CR. We're thinking about all these host requirements too. So this is why I always say that the telco industry pushes Kubernetes to its limits, right? Because the kind of requirements that we have for Kubernetes are similar to what other industries have, but we make everything extreme, right? It's not just that we need a CRD installed before the CR. We might need a BIOS configuration happening before we even get to that CR. So all of this stuff is not even telco specific. This whole presentation could be applied in other industries too, right? This idea of you have to think about this bifurcation problem, and you have to deal with this problem and solve it in creative ways. And I think we are out of time, but I'm happy. I'll be on Slack, and if people want to continue to talk or put something on the agenda for next time, and we can definitely continue to discuss, or we can move on. If you think all of this is clear and not very useful, we can just continue with our Nephio work.
Well, thank you, Tao, for the presentation.
Thank you for the great comments and for the patience.
Yeah. Continue any discussions on Slack, or or if you put in next meetings agenda items, if you continue the conversation. Thank you for coming.
Yeah.
Thank you. Have a great day, everyone.
Thank you, Tal. Bye.
Bye.
Bye.